Hello. So I'm going to take you through some updates of Cerebral 2. I got a lot of work done this weekend, and it's actually shaping up pretty nicely now. So I'm going to talk a bit first, and then we'll write some code, and hopefully everything works. I haven't really prepared the code part, but okay, let's have a look. So first I'm going to talk about how views work. Like you can choose between React and Inferno and all this. But actually how they update and stuff, I'm going to talk about that. Then I'm going to talk about the router. And then about computed. Some other things that has also been fixed is that now time travel debugging works, even though you don't have an immutable model. And it's actually an option because it needs to store all the mutations and it has to stringify the payloads because they might be mutated. So that's a way to avoid mutation of stored mutations, kind of. But we have to do that anyways because the payload has to be stringified to pass it to the debugger. So in that regard, that's not an issue. But it's currently an option. Because now it actually stores all the mutations as well to be able to replay them. But I think maybe that will be necessary anyways. So it might just be on by default, because if you run multiple Cerebral apps and you change between tabs, I've done a different strategy now. So instead of the debugger having multiple instances of different sessions, it's just super complex. And now the idea now is that when you change a tab and the app is focused, it will actually reinitialize. It will as if you time traveled to your current spot. And it does that by sending the initial model and all the mutations. So yeah, it might not be an option, but currently it is. So just to be clear, that it will always be on. And then model up. Yes, so in the debugger now you can change values and the app will update, but it won't trigger a signal now. Like before, it actually triggered a signal, but that's not necessary anymore because now the debugger is or the dev tools as they're called now, is actually part of Cerebral. So there's lots more flexibility and making it the best possible experience and the best possible code to contribute. Yes. So you're your signals will be kept clean. It's only app signals there, nothing related to debugging. Yes, and also fix so that the view tab in the debugger works as it's supposed to, I think. At least it works. And also the debugger in general I've done a lot of work on it. Like the Chrome extension is a lot cleaner now. The way it communicates, like how it triggers the debugger, is a lot cleaner. Like it sends the minimal amount of information that is needed to get it going, which is important. Like if you have a large initial payload, for example, it's just more as it should be now. And generally throughout the code, there's lots and lots of optimizations and just general improvements. Okay, so let's look at the views first. So what I mean here is what we usually look at as Cerebral, View, React, and so on. I've done a complete refactor, cleaned up the code using ES 2015. So it will be like all of the focus now on Cerebral2 is to write as clean code as possible to make it easier to contribute. Yes. And then we have the signal. So when you connect a component, you could choose to not be explicit about the signals to inject. Now you have to be explicit about it. It's just cleaner. So if you need signals, you have to be explicit about connecting those signals. And then strict render is forced, and that's just because it's faster. And Cerebral has a very unique ability that other frameworks does not have, and that is I will go into this later, but it has the ability to choose what component that should do a re-render without any none of the components do actual checking of should I update, checking immutable values and stuff. It's just the top container just knows what changed, and it knows what components that depends on the change, and it will tell it to re-render. And with strict rendering, it's like the fastest. I will go into this later. And then I also created a generic implementation of this. So like the container component and the connect and the higher order component thingy, it's completely generic. So like for React, it just passes in React, and for Inferno, it just passes in Inferno, and for React Native, actually I think React Native is not, because React is React in terms of connecting and stuff. React Native is like React DOM, I believe. So you still just use React if you use React Native. Anyways, we'll figure that out later. But the really cool thing here is that to figure out what should update, everything's based on paths and changes to paths. And to handle this in a good way, I created a concept called a dependency store. So like when you fire up the container for React, that container has a dependency store. And it's just super optimized code. Like a lot of the work done in Cerebral has been like experimental, and it has been more important to prove the concept than writing like the best code for it. And also like releasing it, getting feedback, and all this stuff makes you think about, oh, maybe I could solve this a better way. But anyway, what happens there is that in this dependency store, it's possible to add an entity with a dependency map. So for example, you could add a component which has a dependency map that looks like this object here, where you want the property to be foo, and the path is app.foo. It's also possible to remove the entity. And you can also grab entities based on a change map. So you kind of like add entities with their dependencies, and then you can call a method which passes in a change map, which looks something like this. And you will get back the entities that matches that change map. And it handles this asterisk and double asterisk thing, which means that, okay, I am interested in changes on this specific path, or the immediate path, or all nested paths. We'll talk more about it. And then this dependency store is used both by the components or the views and the computed, because they're exactly the same concept now. And it just reduces insanely much code, and like relatively insanely, and it's much easier to reason about the code. So then we have the router, and I wanted to try this first, and I think this actually is a really good idea. It is to integrate the router with Cerebral. Of course, you don't have to use the router, but you just import it, and then you add it to Cerebral. And the thing is that this is monolithic, so you don't have to install a second dependency, but it also allows us to integrate it better. In terms of, we don't have to create special API to make the router hook into where it needs to hook into. We just do it where it makes sense. So that kind of like doesn't affect the general API. I've also rewritten all the tests for the router. It's not that the initial tests were bad at all. It's just that I want it to be super easy to contribute. And the previous tests had some very custom test setup, so it was difficult to understand what each test was kind of like setting up and testing. But now that is more explicit, and it's also using Mocha like the rest of the tests. What's kind of cool is that when we integrate the router with Cerebral, we can do some pretty cool stuff. Like for example now, when you define the routes, you can do that on the controller as you used to. But you can also define them in the modules, and I will show you very soon. So kind of like you have the routes at the top level, but if you create a module named admin, for example, and you define routes there, it will automatically think of that as the URL admin / because the module name is admin. So we get like nested routes for free inside modules, which is super awesome. Another awesome thing is that now it's very easy for us to expose this crucial method for converting a signal into a URL. So typically you want to create a hyperlink, and you want that to be like text. You don't want to have an on-click triggering a signal. You want it to be an actual URL. And that is no problem when it's integrated with Cerebral. I'll show you that in a second as well. And then we have computed. As I said, it uses the same implementation as the views for dependency handling. Reviewing that dependency management, optimizing it, it will help both computed and the views. But it's very good now. So it's not that likely that it will change, but it's easier at least. And also, like, there was some caching logic where we stringified props and function strings and all this stuff. That's not needed anymore. Now, like, each computed is like an instance, and it just these instances gets flagged whenever there's an update from the model, and then when you grab it, it knows if it needs to recompute or not. So that's pretty cool. Yes, and I also rewritten tests for that, taking into account tests for like strict rendering and stuff, because computed works the same way. Like a computed can be interested in immediate or nested paths. And yeah, maybe most importantly, when components now unmount, they will actually clean up the computed. They didn't do that. They don't do that right now. But it wasn't seen as an issue, or it was a postponed issue if it would be a problem. But now it was so easy to implement it that I just did it. So whenever a component unmounts, any computed related to that component will be removed from memory. Cool. Okay, so I thought I could kind of like show, it might be a black box now, like what's happening, like how does the components know how to update and stuff. So I thought we could take a look at that. So imagine that you render an application with the container. And then you render one or multiple components wherever in the virtual DOM tree. What happens is that when this component mounts, it will actually call a method on the container where it adds itself. It tells the container what state dependencies do I have, and then that is kept in the container. As you can see here, this component down here depends on app.foo. And then it passes that when it registers to the container. And the container has its own map where each of the paths active in the application has one or multiple components related to it. So it knows what components depends on what paths. And then, if the component unmounts, then it's removed from this map of what paths relate to what components. Yes. And then, for example, this component fires off a signal. And this signal goes to the controller, it runs the signal, and there might be an update to the model. And then what happens is that there's like a flush event triggered on the controller. And that flush event has, which I just called changes here, has an object. And this is the flush object or changes object, which tells what paths has actually changed in the application, inside the model. And then the container will traverse these changes, and figure out, okay, what components actually depends on this. So in this case, it sees that app.foo has changed, and app.foo, we have a component, and it tells that component to render. And this is what makes Cerebral different. Typically, when a change happens in a React app, all the components needs to figure out if their depending values has changed. Okay, all of them. It's still very fast, but it's kind of unnecessary. But the Cerebral doesn't change values; it changes paths. So that means that we don't need immutability, and we also, like, typically you change very little compared to everything. Like you maybe change just one path, and that's very and then the container only needs to figure out, okay, what components relate to that path, and tell them to update themselves, instead of all the components checking all their values if they changed. So that's actually pretty cool. And then we can do this thing like the strict rendering, like I am interested in this specific path and my immediate paths, or all nested paths, which also improves the rendering. So it would be really cool to see, like most benchmarks are not about optimal rendering, like doing things like this, because nobody has really done it before, as I understand. They're more about like pure force, like pure render force or diffing force. So it would be interesting to see, like in a project where there is a lot of state, and you have this approach compared to diffing the values, see how much faster it is. But in theory, it should be a lot faster. What takes time is the actual rendering. It's not the diffing, but it does should reduce the time spent diffing, because it doesn't diff. It just traverses this small changes map and then tells what components to update. Okay, so there's still some work to do. I'm currently commenting all the methods. Like the code now is based on classes. It's just, like I said before, I would never use classes to write an actual application, but it's really nice for libraries because it's so focused and it's not that much code. And you have the methods, like you're exposing a set of methods, like you have an API. So it's a really good way to write libraries, I think. But anyways, I'm commenting all the methods. As I said, I want this to be a code base that it's easy to contribute to. But there's also small things like copy signals in the debugger has to be fixed, disable the debugger, identify execution, time travel. What was that? Oh yeah, if the debugger, like you can time travel, if you do time travel while a signal is running, it can cause some weird things to happen. So maybe the debugger needs to know about when things are being executed, so you can't time travel while it's executing. Stuff like that. I need to write some more tests, and also introduce Inferno here. And I see that some people are still using Snubdom. So we need that still. And also the server controller. So Cerebral on server side, my opinion is that Cerebral shouldn't run on the server. Like what you want on the server is it's about the components. You want to render a string based on components, and those components just need some state. Like you want to prepare some state, and then you want to render your components as a string and pass that to the client. You don't want to run signals, initialize the router, and all this stuff. It's all about preparing state, render your components as a string, and pass it down the wire. So this server controller is maybe not even a controller. I'm thinking about having like a server container instead. where you, instead of passing like a controller, you just pass some state into it. And then that's enough to actually run the application. Or sorry, to convert the components to a string thing. Yeah, okay. Cool. And all this just makes it a lot easier. It's like, how does Cerebral support like universal apps? And yes, it does. You just have to pass the state you want your application to be in into the container. That's universal Cerebral apps. Because it's just insanely difficult to, like, running a route on the server will never be the same as running it on the client. Running a signal on the server will never be the same as running it on the client, because they need to do different things. So it's kind of silly. But then Cerebral2 runs some function tree. So if you want to reuse like Cerebral on the server, you can just use function tree, because that's basically the same thing. And then you don't have all this other fluff of which is more like related to the browser. Okay, anyways, let's look into some code now. All right, so I have a Hello World application here running on React, and I can show you now. Hello, Cerebral beeps, and it updates. So now this part works, which is nice. So what we can see here now is that I import, and I call it the DevTools now, just because debugger is a keyword in the code. So we just avoid where we want to call it debugger and where we can't, because it's a keyword. DevTools is a better term. And yes, I instantiate a controller here, and I given it some state. As you can see, the DevTools is added, and now you don't have to have like an empty function or all this stuff. You can just do null if you don't want, like if you check for production. And as I said, time travel is now an option, but due to the behavior of running multiple Cerebral apps in different tabs, it needs to be on by default to rebuild the state of the debugger when these tabs are changing. Okay, so what I thought we could do now is I can show you the router. So how should we do this? Well, first I can import it. So I import the router from Cerebral router, and I add this just like the DevTools router, and I can say things like query true hash URL and all this stuff. But let me just instantiate it. And this initializes the router. And now I have the ability to define routes. So for example, if I now write routes here, and I say that this should trigger a routed signal, and I say signals routed, and we'll just set the title to I was routed. And then we have to import set from Cerebral operators, like that. And if I refresh now, it says I was routed, and we see the signal. So that's awesome. But let us now add a module here, and we'll see how the router can handle this. So we say modules, and we call it admin, for example. And yeah, let's just call it admin module, and we'll import that admin module. Or maybe I can just do it inline. Yeah, let's just do that. So we have a const admin module, and this can be just an object, or it can be a function that returns an object. Okay, we talked about that last time, but I'll just use an object now. So you would imagine this being in a different file, of course. But what I want this object to have is also to have routes. So the thing is that because I have admin as the name of the module here, it will say that this is actually admin automatically. And I think Alexei was playing around with this meta router and stuff. I didn't never looked into it, but I think this was the thing you wanted to achieve. Anyways, so let's also just trigger a routed signal here, and we say signals routed, and then we say again set state title to admin, and then we'll see here, instead of I was routed, front page, we can say that. Okay, so now we have a module where we have defined some routes and signals, and that should be okay. So if we refresh, it says front page. Okay, cool. So what we're going to do now is create two links, one that goes to the front page and the other goes to the admin page. And then, as I talked about, now we have to be specific. Is it front routed? Be specific about the signals we want to use. So we say front routed, and that was just routed. And then we have admin routed, which is inside the admin module, but it's also called routed. And then we have href. And what we can do now is that since the router is an integrated thing in Cerebral, we can just say props front routed to URL, just like that. And we can say admin routed to URL, like this is calling the signal, this is converting it to a URL, and we say admin there. So what should happen now is that I have two links, and I click admin, and it changes to admin, and I click front, and it changes to the front page. So as you can see, it's like it just kind of works. You don't have to install anything. You just put the router in there, and now you can do routing the way you want, either at top level or by module. So I think this is super beneficial and very, very easy to understand and get going with. Cool. And then we have computed. So computed works the same way, like you define the computed, and you kind of like just have to trust me that it gets cleaned up and all this stuff. But yeah, I can show you. It works exactly the same way though. Uppercase title computed from uppercase title. Okay, so we do this and we say upper title and we call it, and then we can say h4 is props upper title, and like that. Oops, I have to go to the root, and it's uppercased front page, and yeah, it changes with the page there. We could, for example, insert a component here, upper title. Let's create that folder, upper title, so that we kind of put it in its own component. So let's give that also index.js. Just copy this stuff, and we'll remove the title because this only depends on the upper title. And it's h4. Yeah, it basically just has to return that. And props, yeah, just call it title. Props title, and this is the upper title component. Okay, cool. And let's remove it from this part and rather import upper title from upper title. And we'll render that as, yes, we're doing that now. It should be the same front page. Oh, it didn't update. That's weird. Okay. Uppercase title. Yeah, that's weird. Oh, that's a bug. Okay, so Maybe we should just stop there. I have something I need to do. But I wanted to show you some code. Code here first. Wow, that's super weird. Okay, there's probably something I've done wrong somewhere. Okay, but again, all this code is very simple. It's just a bunch of methods on a class. And as I said, I'm commenting all of this now, so it should be easy to understand what each of these methods are actually doing, like conceptually. And like React now, the connect is like it was, but like as you can see, the container just passes in React. And if we go to view factories, we have the container, and now it's like a class, and it's the code is just cleaner than what it used to be. And as you can see, it's using the dependency store. Oh, that's something entity. That's a bug. Cool. Yeah. So I just wanted to show you that the code is kept as clean as possible. And yeah, I suppose that's pretty much it. I should fix this problem first, but I will notify you when you can test it. So like now I'm running like a demo here. So I just do in this branch, when you install the dependencies, you can do npm run demo, and then you run this file that I've been playing around with. So when it's ready to be tested, you can just use this demo to play around with it. I've also added a build script. So it builds each of these different parts into a dist folder. It doesn't create like a library. And it uses a library. I messed around with this. Like, how should we actually build this? And I think the best way is to use common.js, because nobody's using Bower or anything. We might have a separate build script to, if we want to have like just insert Cerebral with a script tag. But like the 99.999% use case is to use common.js. So it does that. Cool. I guess that's it. Okay, I hope this made sense. As you saw, I have some more work to do. But yeah, awesome. Talk to you later.